So these videos are going to go over what are called symbioses. Symbioses is plural for symbiosis, and it just means a close interaction between species. I'm going to be talking about 5 of them in 5 separate videos: predation, parasitism, competition, mutualism, and commensalism. This video is on predation. Predation should be pretty clear and straightforward when you have one individual, which is called the predator, captures, kills, and eats another individual called the prey. This is going to influence where and how species live by determining their relationship in the food web. Now, the videos are not going to work, so I can upload them later. So natural selection is going to favor adaptations differently between predator and prey. The predators are going to have to become better at finding, capturing, and eating prey, where the prey are going to have to be better at avoiding, escaping, or even discouraging predation. So one example that we can look at is a rattlesnake. A rattlesnake has a sharp sense of smell, but they also have these specialized heat pits below their nostrils, and that is going to allow them to hunt even when it's dark out. So based on this picture here, we've got the nostrils, which are there, and these are the heat sensitive pits right there. Kind of like infrared or like a thermal blah blah camera. I can't think of the name of it. Whatever that thing that the military use when they like look at a building and they see like the bodies running around. Thermal camera? I want to say thermonuclear, but that's so not right. Anyway, you get the idea. Other predator adaptations. You have the spider with its web, obviously. These are really cool because spiders instinctively know which strands of theirs are sticky and which strands are not. So they know how to walk on their web without actually getting caught in their own web. If you ever wondered why a tiger is orange and black stripes, you think that doesn't really seem like it would be very good for hiding. But where you look at where the tiger is, like in places like India where they have like these long, tall, brown grasses, it melds in perfectly. And then of course you have the great white shark, which I think I've talked about it before in some other context, but like the difference between the top layer of teeth and the bottom layer, I call the bottom layer the fork and the top layer the knife. So the bottom layer, they're sharp and pointy, so they work to stab and grip the prey, while the top layer, let's get a close-up of one of these badass teeth. The top layer here you can see is serrated, and that's meant to cut through the flesh just like your knife is. So because sharks don't have hands, so they can't like grab their prey and rip a bite off, what they do is when they grab onto prey, they will shake their head back and forth, and those top teeth use those serrations to act like a knife and cut through the flesh. On the other side, the prey has to be able to adapt and avoid being caught. So natural selection is going to favor anything that helps the animal or the plant avoid, escape, or discouraging predators. This could be running faster, being able to hide, or even being poisonous. So let's get a couple of examples of adaptations that allow animals to hide. So looking at this picture, can you find the bug? I'll give you a hint. Here's the head. See it? The head. Here's the body. This is a praying mantis. And then here's the arms. So the head, the body. I think there's another leg here. Maybe it goes on like that. I don't know. But that's praying mantis. Camouflage. This is a different kind of camouflage. You're not actually trying to blend in with the actual background, but you've literally mimicked a dead leaf. So you can see the head, the antennae, a leg, but it really looks like a dead leaf. Can you find the bug amongst the leaves? I do believe this is a leaf bug. We've got antennae here. Yeah. Here's the head. Looks kind of like this leaf here. The body. See it? Freaking amazing, huh? And the last thing, another kind of half dead / rotting leaf. You can see the antennae there. Here's the antenna, body, and a leg coming out here. So that's one way to avoid being eaten, is if they don't know that you're there, and then they will just avoid you. How about being poisonous? We all know the famous warning coloration. We also have, this is a stonefish. Doesn't really have warning coloration, but these spikes all contain poison. Oftentimes, people that are swimming or wading in the ocean will accidentally step on them. I've heard it's painful. Here's some other bright stripes, and of course, a bright ass green frog. Now, another way that you can escape is not necessarily by being poisonous, but by looking like something that is poisonous. So you want to trick your predators. This is called mimicry. There is two kinds of mimicry. I remember one of them is called Predation, and I can't remember the name of the other one, but basically you have two versions. So either you're harmless and you look like a harmful species, or another example is when you can have more than one species that are all dangerous. They all kind of look similar. And an example of that are bees and wasps. I think that's Bayesian. I can't remember. Don't quote me on that. I haven't studied this for a while. But for bees and wasps, basically you're looking at the kind of mimicry where you're like, anything that flies and that has yellow and black stripes, I'm staying the hell away from. All right, so here is an example of a harmless species mimicking a poisonous species. So at the top, well, first, before I tell you which one's which, I want you to just see the difference. Yeah, I'll use green. The difference in the order of the pattern here. So if you basically look at, like, say, the black part, it's surrounded by yellow stripes. And down here, it's yellow surrounded by black stripes. Or you could say it goes like orange, yellow, black, yellow, orange. And this one goes orange, black, yellow, black, orange. But you see how similar they are. So it turns out that the top one is the poisonous one. It's called the coral snake, very poisonous species. The bottom one is the scarlet king snake, totally harmless. But are you going to try to figure out which one's which? Nope. You're going to go bye-bye. And let's say you just end up wanting to look like the predator of your predator. So here we have a caterpillar. How do I know it's a caterpillar? Look at these cute ass tiny little feet back here hanging onto the branch. Caterpillar. What eats caterpillars? Birds. Birds eat caterpillars. What eats birds? Snakes. Snakes eat birds. So this is a way to avoid being eaten if you look like the thing that eats the thing that eats you. I think owls do the same thing. Owls have like, let me get out of here and go to here. Come on. So annoying going back and forth between screens. Let's say owl. Oh, no. Sorry. Camouflage. It's not an owl. I don't know. Owl, let's see, moth, owl eyes. Okay. That's what I want. Okay. So this is another example of looking like the thing that eats the thing that eats you. So moths are often eaten by like insects or small birds, and then what eats the insects and small birds are predatory owls. So you'll have the moth wings. I mean, look at this. That looks like a freaking owl face, like exactly like an owl face. That is freaking crazy to me. Absolutely insane. So this is a way that prey can avoid being eaten. Let's go back here. Super annoying having to switch between screens. All right, what else we got? Okay, one last example of mimicry. Down here we have what's called the monarch butterfly. As a caterpillar, the monarch butterfly feeds on milkweed, which produces this kind of milky, extremely bitter sap, and it makes makes the monarch butterfly taste very bitter. And here you have the viceroy butterfly, which for predators would taste fine, but it often gets mistaken for the monarch. So again, if you have experience as a predator and you eat a monarch and you're like, oh my God, that tastes like shit, then when you see a viceroy, you're like, oh no, last time I had that, that tasted horrible. I'm not eating that again. So then the viceroy is saved. And again, these videos won't work. Okay, the last part about predation. You probably don't necessarily think about herbivores as being predators, but they are because they prey on plants. So there is a predatory prey relationship between plants and herbivores. So plants are going to have to evolve to protect them from being eaten. This happens in two ways, either physical or chemical defense. Physical, I'm sure that you can guess, thorns, sticky hairs, or tough leaves. Why tough leaves? It makes them hard to eat. So you've got the cactus, I forget what plant that is, maybe honeysuckle or something like that. Or you have plants with thick ass leaves that are just really hard to eat because they're so thick. You also have chemical defenses. Part of the metabolism of plants, they make something called secondary compounds. Secondary compounds could be good or bad. When they're trying to defend themselves, when the plants are defending themselves, the secondary compounds can be poisonous, irritating, or bad tasting. I'll talk about the beneficial ones after this, but as an example, we have strychnine. Strychnine is a poison that kills people, and it comes from the plant called strychnos. I believe it comes from the flowers. Other examples are nicotine. Now, nicotine is the chemical in the tobacco plant that makes tobacco addictive to humans, but that is not the reason why nicotine evolved in the tobacco plant. The reason why nicotine evolved in the tobacco plant is because it's toxic to insects, and insects are a predator of the tobacco plant. There's also poison oak, poison ivy, which I don't know if you have here in Thailand, but we do have where I grew up. And you can see, here's one petiole and here's the other one. They come in leaves of three. So there was a phrase that we learned growing up called leaves of three, let it be. Normally, poison oak, poison ivy, they just create like a really, really itchy rash. But if you're allergic to it, you can get really big blisters. The dog just groaned. Okay, so I also told you that secondary compounds can be beneficial. One of the most interesting classes I took in university was called ethnobotany, and it was basically how humans throughout history have used plants. And I swear, like the first half, I thought was just like drugs 101 because we talked about marijuana, we talked about peyote, which is a mushroom that is used in like religious ceremonies for a lot of Native American, both North and South American Native American tribes, because it makes them high, and then they go into like the little sweat lodges, and it's like 5,000 degrees, and then they hallucinate and they become closer to God or their ancestors or whatever. But it was a very interesting class because there are so many species of plants that we just haven't discovered, and you think about the Amazon. And what possible medicinal compounds we could have yet to find there if we don't burn it all down first. Oops. So examples of medicinal secondary compounds, we have morphine. I don't know if any of you have ever been in an accident or had surgery, but generally afterwards they give you a painkiller through the IV drip, and that is morphine that comes from plants. We also have atropine, which is used to treat glaucoma, which is an eye disease. We have codeine. If you've ever had a sinus infection or some kind of upper respiratory infection, you might get some medicine, a decongestant with codeine. It makes you kind of sleepy and really relaxed. There's Taxol, which is used in cancer treatments, and quinine, which is used to treat malaria. An interesting historical story about quinine. I don't know if any of you are history buffs or you like anything about history, but when I was in school, I hated history until I'm out of school and I actually like read stories or like watch documentaries about it, it makes it much more interesting. And I never understand why they can't teach history that way, like in documentary style, because it's really fascinating. Anyway, during the Second World War, Americans were fighting on two fronts. There was a European front where they were fighting the Nazis in Germany, and then there was the Pacific front where they were fighting the Japanese. And at one point, like the quinine comes from a tree, the bark of a tree. And this tree is found in Southeast Asia, like in the Pacific Ocean, where they were fighting. And during one battle, the Japanese actually took over this one island, which was known for having I think it's a chicon or whatever kind of tree quinine comes from. And it turned out that that alone completely stripped the Americans of their ability to get quinine. And so a lot of American soldiers died of malaria because there was just no treatment for it. And thus endeth the lesson.